Let me start the recording. So, why or what is data compression and why we go for compression of our data? So, compression is actually transforming the way information is represented. That they should save our space as well as our time. The type of compression we can have is lossless, where the compressed information can be decompressed into the original information, such as zip files, while in other lossy techniques, where the decompressed information differ from the original but ideally in an insignificant manner, and the example given is JPG compression. So let me explain over here that why data compression, why we go for data compression. What is the main reason behind that? So number one is we have less space on storage devices. And similarly, we also have low bandwidth, which can carry your data, low bandwidth to carry data. But how we can actually compress data? Compression of this data is the removal of empty slots inside our data. And let me explain over here. For example, this is a CD structure, and over here you can see these are sectors, and between these sectors we have small spaces which are called guard bands. And actually these guard bands, this is for example like a security guard, which will not allow data from this sector to come over here or to mix with this sector. So actually these slots are used as a boundary wall between two sectors. And similarly, if you store data in multiple layers on a CD, like for example, there are 3 layers as we do in DVD. So through these boundary walls between our guard spaces between different sector, you can access the lower layer of your data. And similarly, over here, you can access the lower layer on the CD. So in compression process, you actually compress these guard bands, or you can say the boundary walls between sectors. And that's why sometimes there is a possibility that you lost some data. And especially if you are in hurry to compress this data. So this is all about that how data compression take place. And similarly, if you know about the spectrum for communication, we also have guard band between different frequencies. For example, this is F1, this is guard band. This is F2, this is guard band. This is F3, this is guard band. And this is F4. So actually, if you compress these frequencies with one another, you will press this guard band to create more space. So this is the main approach behind the guard band mechanism. Over here, compression talk of the size and rate requirement of multimedia system. Multimedia files are often compressed into smaller form. And look at this, the size will automatically decreases when you press these guard spaces. For example, in MPEG compression, which stands for Moving Picture Expert Group, the MPEG organization, which works with the International Organization for Standardization, develops standards for digital audio and video compression. And we have different types of compression. For example, here you can see there is MPG1 in which you can compress 30 frames per second. In MPG2, used to compress DVD and HD TV transmission as well, while in MPG4, used to transmit audio, video, and graphics can be delivered over very slow connection, such as 56 kbps, because with compression, you actually minimize the size of those audio or video files, and that's why it is manageable for the user that it can transfer it. Over here in this table you can see that we have three compression techniques, then their official names, their standard groups, which where it was developed, and then the compression ratio as well. So in JPG was developed by digital compression and coding of continuous tone still images. And it was developed by joint photographic expert group. And if you can see the compression ratio, it reduced the size by 15 times. In H.261 RPX64, which is a video encoder and decoder and developed by a specialist group on coding for visual telephony, it reduced it from 1 to 100 or 200 times or 2000 times, and that's why you can see over here that you can carry or you can transfer or you can transmit this video or this clip on a very low bandwidth. The third one is MPG, coding of a moving picture and associated audio, which was developed by moving picture expert, and it also reduced the size of a file 200 times. There are certain issues in operating system. You should know that the operating system must guarantee the specific data rate and timing requirement of continuous media. We already discussed this topic in terms of streaming, that if there is a stream of data, then the operating system should ensure that data should be delivered in the predefined time schedule. Otherwise, the destination node would not be able to make any decision based on uh, partially received data. This requirement is also known as quality of service requirement, which is important for any user. And you know that the quality service is guaranteed in many systems. If you are getting a free service, if you are getting a low quality service, it means that is not guaranteed by the service provider. But where it is guaranteed, you should claim uh, uh, for the quality which was promised earlier with you in the contract document. So guaranteeing quality of service has the following effect in a computer system. Number one is, what is the CPU processing time? Either the CPU would be able to provide response to every process in a particular time, or every process has to wait. Next is the scheduling decision. How fast is the scheduling in this system? Either it is round robin based scheduling, either it is shortest job first, either it is a kind of slot based reservations, and similarly what kind of file system it is using, and then the network protocol used for communication purposes. The requirement for multimedia operating systems are divided into three levels. The first one is best effort service. There are three levels. The first one is best effort, which means that the system will try its best to provide or to guarantee the necessary quality of service for communication. As we discussed in yesterday's lecture, that the quality of service for for simple data transfer, for images transfer, for audio transfer, for video transfer, for live chat will vary from system to system, or from communication type to another type. And over here, if you can see, in best effort, the system will commit to provide the required quality of service. There is soft and hard quality of service. In soft quality of service, it allows different traffic stream to prioritize. However, no QoS guarantee are met. So look at this. In soft quality of service, you can see that the system is able to define priorities for certain system. So for example, if any process is more important, then it should be given highest priority, and then onward the system will respond accordingly. In hard quality of service, the QoS requirements are guarantees. There is no priority actually fixed. Once the system decide that I will assign resources, or I will provide this much quality to my clients or customer, then it is fixed. There are certain parameters based on which you can judge, or you can define the quality of service as well, that how much the quality is achieved or provided in any particular communication. So the first one here is throughput, where throughput is the total amount of work completed during a specific time interval. So what is the total uh, amount of work that has been done in any particular time? Let me explain this throughput here, that how we actually use throughput into the communication. So here you can see that throughput is the combination of total data. For example, there is a sender, and here is the receiver, and the receiver actually send data. The sender send data to the receiver, and for sending of this data, the header or control information is added over here with this data, the control information. So for example, it is transferred over here, and then onward this is header and this is data. The user actually remove this header and provide the actual data to the user. So for example, if you are going to send 90 KB data to the user. And over here 90, or you can say 90% or 90 KB data is received. So in this case, the throughput is 100%, right? But in this 90 KB, if you can see, you also have this header which is called control data. Look at this. And this is actually the overhead on the system. So beside this throughput, we have a good put as well. And good put is actually throughput minus overhead. So for example, in this scenario, the overhead is 20%, for example, then 90% minus 20% is equal to 70%. So 70% is your actual data that you transferred and it is received. Then now you are going to judge based on actual data. The data which a user or sender wants to send, and that is not including overhead. So moving back to our lecture, you can see over here, this is the throughput, the actual data you have. Next we have the delay. The elapsed from when a request is first submitted to and when the desired result is produced. And similarly, jitter refer to how variable latency is. So let me explain it over here again on the whiteboard that what is delay and what is latency and what is jitter. So for example, this is a student who is going to university from his home, and here is the university. So for example, if this student start traveling at 10 a.m. and he reach here in normal scenario at 10:05, so it means the normal time to approach this is 5 minutes. For example, if he start his traveling at 10 a.m. and he is reaching here at 10:05, 10:08, for example. Let me, so here you can see there is 3-minute delay. Delay is 3 minutes. The normal time is 5 minutes and the delay here in this is 3 minutes. So when you take the delay in round trip time, RTT, round trip time, he start from here at 10, he reach there at 10:07, then he starts moving back at 10:08 and reaching here at 10:15. So you can say when you are taking delay in round trip time, that he start from here and then he is coming here, That is called round trip time. So if you can see that 5 minutes from this side, 5 minutes from this side, the normal time is 10 minutes, but he actually taken 15 minutes. So 5 minutes is actually latency. 5 minutes is latency. Here 3 minutes was delay. When you take it in round trip time, then it will become 5 minutes over here. This is 5 minutes, this is 3 minutes. And similarly, you can say that fluctuation in latency is called jitter. And the reason is that the situation or the condition on the road or the link is not always same. Sometime you will start your destination from here, you will reach here at 5. Sometime you will start your journey at 10, you will reach at 10:08. The next time maybe you start at 10 and then you reach at 10:12 because there was too much congestion on the link. And that's why there is a bit fluctuation or variation in latency, and this is called jitter. So I hope it's clear now. Now moving toward next step. Over here you can see that next, yeah, next is reliability, how reliable this service is. And reliability is actually directly related to that how much you can rely on this service. Look at this, how errors are handled during transmission and processing of continuous media. And this is the good put, as I told you, that this is the actual data that you send or you want to transfer to the receiver. There are certain flow specification, and you can see that these specifications are defined here in RFC 1363, which define the QoS parameters for bandwidth, that how much bandwidth will be required. So similarly, the latency and jitter constraint, you can see over here the minimum and the maximum delay inside a system. Similarly, the data loss limit, either it is the loss sensitivity, the burst loss sensitivity, or the loss between interval. And taking all those things is actually very important to have the standard quality of service. Let me tell you, this RFC stand for request for comment, which means that, for example, if you are going to standardize something, you can request for a comment. RFC is actually request and this request is for the experts, that you, if you develop any want to develop any standard, then you should take the review or review by experts. As we have testing in software houses, software, like we have the black box testing, test by initial user, test by some expert, test by anyone, any group of people. So look at this. This is a kind of testing that is given over here. This RFC document becomes standardized once all the question raised by the reviewers is addressed. There are certain more QoS issues. The QoS may be negotiated between the client and server. And as I told you earlier, that the capabilities of client and servers are different from each other. And it may vary. And that's why, for example, a server is able to provide more data, or for example, 500 frames are packet per second, but the other user, or you can say the client user, is unable to receive data with the same speed. So there may be, as we discussed even specifically in heterogeneous scenario, this problem may be more severe because the server is capable to send more data, to absorb more data, but the user is not able to provide with the or to receive with the same speed. Similarly, operating system often use an admission protocol algorithm that admit a request for a service only if the server has sufficient resources to satisfy the request. So this algorithm is actually used if the required resources are available with the server. In multimedia system require hard real-time scheduling to ensure critical tasks that will be served within timing deadline. And as we discussed, that hard real-time systems are those systems which 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 don't compromise on any delay in the data. You must meet the deadline, otherwise the system will crash down. You would not be able to process that data if you don't meet the deadline. Most hard real-time CPU scheduling algorithm assign real-time processes static priority that don't change over time. As we discussed that there is static and dynamic priority. The dynamic priority actually changes with time. For example, in university, we have dynamic priorities, and it depends that who are actually coming over there. What is the role of that person? Either he is the chancellor, he is the dean, he is the provost, he is the faculty member, he is the student, he is the staff, he is from administration, or where they are. So they have a dynamic priority. And similarly, they also change these priorities based on their position. For example, someone promoted, someone demoted, but over here in hard real-time system, you have fixed priority, and that is statically assigned by the system. In this scheduling, algorithm must be optimized to meet the timing deadline and rate requirement of continuous media. And here you can see the two algorithms used for scheduling purposes. The first one is earliest deadline first. So all those uh, processes who are whose deadline is first will get the resource earlier. And similarly, the next one is the scan EDF, scan earliest deadline scheduling algorithm, which is also used with different processes or with different program in such type of system. This scan EDF is mostly similar with the EDF, except that requests with the same deadline are ordered according to a scan policy. And a scan policy is a predefined policy for every system in which they actually decide the issue between processes with the same priority. For example, you have two processes and their deadline is same. And then you have to decide between them that which one is more specific. For example, there is a system process and there is a user process. Then automatically, as per scan policy, the system process will get higher priority than the user process. And the reason is that many other programs or processes are dependent on the system process. And that's why in many cases you have to close some user processes by force, and that is actually called killing of a process. When you close processes in uh, in a in a abnormal manner, the actual processing is not complete. The process is dependent on some other processes or resources, and you are closing that process by force. So that is a kind of abnormal closure of the system, and that's why it is called killing of those processes. And in many situations you can see that you close a parent process in an abnormal way, and the children process remain over there, and then those children processes are called abnormal processes. So here you can see, for example, we have this parent class, and this is the child class, child 1, 2, and 3. And look at this, you close this process by force closure. And that's why it is called killing of processes. And when you close this parent process by force, then these children process will remain over here, and that's why they will be called orphan inside the system. And because their parent class or parent process is no more available to protect them. So the priority may vary from system to system based on this technique. The specific one that is first according to the scan direction is served first. Among the remaining requests, this principle is repeated until not request with this deadline is left. It means there is no process or no program with the same deadline. For example, if the deadline is 1 p.m., it means we should assign priority to those processes which deadline will complete at 1 p.m. Instead of 2 p.m., then we will move to the 2 p.m., then 3 p.m., and so on. You will extend it. Similarly, network management between these processes or programs is also very important. There are three journal methods for delivering the contents in multimedia system from server to a client. The first one is the unicast, where the server delivers the content to a single client. And similarly, the broadcast, you can see here in this diagram that we have this server, and he is going to send this data directly to a client. This is called one-to-one and known as unicast communication. And another one is that is one-to-many. For example, this is, so look at this. This is a network of 7 computers, 7 PCs, and he is sending to only 3 or 4 PCs. Let also add this one over here, that he is sending to this one as well. So he is sending to 1, 2, 3, and 4. And this 5, 6, and 7 are receiving nothing. So this is called multicast communication. Multicast, which you send data to a group of people. to a group of user, you transfer or you send this data. The next one over here is the broadcast communication. There is a server and these are the clients. And the server is sending it to everyone. So sending data to all nodes, or you can say to all clients, not only to a group. And this is the broadcast communication. And the next one is any cast communication, any cast, which means that if anyone, here's the server and this is the network, and if any one of them receive this data, it means the task is satisfied. Either it is received by B, either it is received by C, B, A, or to node D. So whoever received this data, it means the task is satisfied, or the goal is achieved. So this is a very important parameter over here that you should know. So you can see the unicast, the broadcast, and the multicast communication. And the multicast communication is with a group of people. Here he gave the example of Signbuild's multimedia server, which support both real-time and non-real-time clients. This server actually provide hard QoS guarantee to real-time clients and using an admission control protocol as we discussed, and the scheduler actually use or request C-scan order as well. As we discussed, the scan EDF with certain policies based on the requirement of the user. Here he has given some example of YouTube as well, which is serving some videos to the client. Here each video is served by more than one machine and hosted by mini cluster as well. Sometimes there is a group of systems or server which are providing this uh, service to the user, and that's why the user don't know from where he is getting service, as many servers are providing service to the user. The most popular content is moved to a CDN, that is content delivery network. And as we discussed about virtual memory in our distributed system, that a place which physically belongs to hard drive, but it actually works as a primary memory or random access memory, and you keep the important programs or processes which will go for execution next for efficiency purposes. And same is the case here, that they use the CDN content delivery network, that they place the most popular content over there, and less popular content is actually uh, moving back to the backing store or to the main storage devices. Look at this, 1 to 20 views per day uses YouTube server in various proper sites. So you can also see that which videos you are watching, the YouTube will automatically bring, when you open a YouTube page, the YouTube will bring automatically all those content of your interest on the sidebar. And another mechanism that is started by the YouTube, that now they are earning money with some advertisement, and they will stop your requested or required video for a while, and they will play advertisement during that time. So as it's a free service, that's why they also use it, and they actually push you or compel you that you should watch their advertisements as well. Videos come out of any data center, not closest mesh or anything. If a video is popular enough, it will move into the CDN automatically. So there is actually the content uh, priority, or you can say the importance, is decided based on the views, the comments, the like, or how many time it's watched or view or accessed by the number of users. So that is the most important parameters which decide between different types of video, either we should place them in the CDN or not. So this is the end of this lecture. And if you have any question, you can ask.